Well, once again, welcome back, everyone. And so we have our warm-up number 27 on the screen. It reads, number one, write the compound inequality shown by the graph. And you have one graph in red. I believe it starts at 1, 2, 3, 4, at -4, and it goes shaded to the right. And then we have another graph starting at 1, 2, 3, 4 at +5, and then shaded to the left. And it keeps going. So let's see if you can write your compound inequality for that. Number two, it says solve, and they give us the equation 2x over 3 plus x over 6 plus 1 over 6 equals -2/3. See if you can solve that one using that process we've been using for rational equations. And then we got number 3, evaluate the function and graph using the domain -2, -1, 0, 1, and 2. And they give us a function f of x equals 3x minus 2. And if you notice, today I'm introducing the function notation already, f of x. You're like, yay, functions, let's go. So yeah, hopefully all the practice that we did in the past, it will kick in today, and hopefully it'll transfer a lot easier. For those of you that were in the Zoom a little bit earlier than the rest, you should be done with the warm-up. So I am asking you to get a Cornell note ready. And also in the Cornell note, set up at least 1, 2, 3, about 4 coordinate planes from -8 to 8 for both the domain and range. All right, I'll give you guys some time for that. How about another 3 minutes? Ready, go. So here goes a warm-up number 27. First of all, we needed to identify what kind of inequality we have. If both graphs are intersecting, such as this one, then we have an and compound inequality. What does that mean? That it's going to be a compound inequality with the x in the middle with the dividing points and the ends. So what are my dividing points? Here's one, here's the other. And we said one was at -1, -2, -3, at -4, and the other one was at 1, 2, 3, 4, at 5. So we take the dividing points, -4, 5, we write a variable in between, arrows to the left. The next step, you need to check to see if the point for each of the dividing points is a solid point. Is this a solid point on -4? Yeah, it's a solid point. Same thing with 5. So that means we need to put an equal sign underneath each inequality symbol. And then at the end, we write our solution set of x such that, and then you just write your compound inequality. Hands if you got that. Okay, good. Let's go to number 2. Number 2 is very similar to what we've been doing with rational equations, but this one doesn't have any variables, if you notice, on the denominator, but the process is still the same. Let me go over that. So for that one, let me make some space down here. Once again, we still need to identify the LCD, least common denominator. What are my denominators? 6 and 3. Question, what would be a common denominator for those two? Well, yeah, we can multiply the second one times 2, so that would give us 6. So our LCD is 6. And I'm going over this exactly how we did rational so you can see the process one more time. We multiply the entire equation times the LCD, but only the numerators. So 6 times 2x is 12x over 3. Plus 6 times x, that's 6x over 6, plus 6 times 1 is 6 over 6 equals 6 times -2, that's -12 over 3. From there, we identify giant ones. You're saying, Mr. Q, but I don't see them, but I can divide them. Yes, but let me show you the giant ones. Can I write 12x in factors where one of the factors is 3? Yes, 3 times 4 times x. So now my giant one is right here. Therefore, that leaves us with 4x plus. This one is obvious. 6 over 6 is the 1. So we're left with x plus 6 over 6 is 1. We're left with 1 equals -12 also, where one of the factors is 3. I can write it as -3 times 4. So that means 3 over 3, and that leaves us with -4. All right, from there. Combine like terms, we're left with 5x plus 1 equals -4. And the rest is history. We just solved by isolating x. So we subtract 1, subtract 1. We're left with 5x equals -5. And lastly, divide by 5. X equals -1. Hands if you got that. All right, question. Here goes a question for you guys. This one does not have any excluded values. Think about it. Why? Why doesn't it have any excluded values? So if we were to be in class, I will have you share with your neighbor, but since you're by yourself in your room, share with your dog or your cat or anyone that's there with you, let them know why that does not have any excluded values. Let's see, help us out, Sachiko. Why does this one does not have any excluded values?
None of the denominators have a variable.
Exactly, no variables on the denominators, because if we were to write the denominators equal to 0, we know that 6 and 3 equal to 0 are not true, and that's why there are no excluded values. We need a variable on some of the denominators. Okay, thank you. Let's move on, and number 3. Number 3 reads, evaluate the function and graph using the domain. So I'm going to show you once again, and for those of you that were with me, this should be a review. Now, we've done all the work in the previous warm-ups that we've done. The only thing that I changed here, who noticed that I changed the y into f of x? You guys notice that? Instead of y, now we have what? F of x, because we're going to start dealing with functions. How do you pronounce this? F of x, or function of x. Let me repeat that again. F of x is function of x. So I'm going to start with my first value, and I'm going to do that in blue, which is -2 for x. To evaluate this function using that, you need to show me which number you're working on. Like this, you write f of, which is the number you're going to be working on, -2, which means you write 3 times -2 minus 2. F of -2 is -6 minus 2, so f of -2 is -8. That's how you evaluate that function. But I need that for all the numbers in the domain. So I'm going to switch colors to red. My next value is -1. I'm going to do the same thing. F of -1 equals 3 times -1 minus 2. F of -1 equals -3 minus 2. F of -1 equals -5. And that's the evaluation of that function with that. I'm going to switch, and I'm done with -1. I'm going to switch to 0. So f of 0 equals 3 times 0 minus 2. F of 0 equals 0 minus 2. F of 0 equals -2. From there, I'm done with that one. +1. So I'm at f of 1 equals 3 times 1 minus 2. F of 1 equals 3 minus 2. F of 1 equals 1. I'm done with that one. And then the last value in the domain is 2. Oops, sorry. Okay. So I'm at f of 2 equals 3 times 2 minus 2. F of 2 equals 6 minus 2. F of 2 equals 4. And those are my evaluations of all the domain using the function given. So before I go to graphing, let me make some space up here. Before I go to graphing, I need a table to show my domain and my range. Here it goes. X, we said was what? -2, -1, 0, 1, 2. And the range, we no longer use y. What do we use? Chi. Instead of y, what would I write?
X.
We already have x.
X2.
Close. Instead of y, what did we say we wrote this time? F of x. So on your table, same thing. Instead of y, we write f of x. Okay, thank you. So what is my range? My range is -8, -5, -2, 1, 4. So we write those here, -8, -5, -2, 1, and 4. All right, let's get our coordinate plane. going to start with my domain. I'm at -2, -1, 0, 1, 2. My range goes from 4 all the way to -8. So I can go by ones. Let's see. 1, 2, 3, 4. And down here we got -1, -2, -3, -4, -5, -6, -7, -8. All right, so let me plot my points. I'm going to do those in red. -2, -8, -2, -8 down here. -1, -5, -1. Then we got 1, 2, 3, 4, 5. It's about right there. 0, -2, 0, -2. 1, 1, 1, 1's about right there. And 2, 4, 2, 4 is about right there. From there, you graph your line, going through those points. There it is. And just to label, make sure we understand what are we looking at. This line corresponds to what? F of x equals 3x minus 2. And that's how the graphing goes for linear functions. So today, we're getting closer to linear functions, which we're going to see on Friday, because Wednesday, there's no classes on Wednesday, on Friday. But today we're going to focus, I'm going to bring back, and it's going to be a review so that you don't freak out on me. We're going to do a review on slope and slope-intercept form. For those of you that forgot, hopefully I'm going to bring this back with all the work that we're going to do, okay? All right, let's move on. Our agenda for today, warm-up number 27. We got 2 variable equations and our home place 10 problems only. Reminder, tutoring right after lunch. And for my periods 4, 5, and 6, I'm moving it to 1 o'clock also, because I've noticed some of you email me and tell me that you can't attend at 2 because some of you go to work. I get it. And some of you are at another session. So I'm going to move it to 1 o'clock, so right after lunch. Okay. All right. So our asynchronous code is XJAD6. XJAD6. XJAD6, your asynchronous code for Nearpod. And here are your 10 problems only. Oh, my bad. Your previous home play was to, I didn't give you any home play for my class, so you needed to catch up with whatever you needed to catch up in my class or any other class, yeah? Did that help over the weekend, yeah? Yeah, you're like, yeah, Mr. Q, I did nothing. All right. Home play. It says compute the slope of the line that passes through the 2 points. And the points given, here we go for number 1, -2, 3, and 1, 5. For number 2, -2, 3, and 0, 6. Number 3, 5, 1, and 7, 9. For number 4, 22 and -18, and -1, -2. Number 5, -1, -3, and -9, -10. For number 6, -9, 0, and 6, 1. For number 7, -3, -2, and 0, 0. For numbers 9 through 10, the instructions are write and graph a slope-intercept form equation. For number 8, they give us the slope of 3 and the y-intercept of -4. For number 9, slope is -4 and the y-intercept is 6. And for number 10, the y-intercept is -5 and passes through the points -3, -2, and 0, 0. So we're going to be looking at that today. So make sure you copy that. And once again, you can use your asynchronous code to come back and get that information from the Nearpod presentation. All right. So just to save time, I'm going to move on. You can get those numbers on your own. Here we go. So our objective for today, I can define and graph 2 variable equations. I can define and graph 2 variable equations. So we're done, guys, with expressions. We started the school year with real numbers, doing all kinds of stuff to real numbers. We went to expressions. Now we're moving on to, and then we did 1 variable equations, and now we're doing 2 variable equations. What are 2 variable equations? So I'm going to give you the whole information so you can just copy it and save some time. 2 variable equations, the definition says 2 expressions equal to each other that contain 2 unknown variables. Again, 2 variable equations are 2 expressions equal to each other that contain 2 unknown variables. Here are the examples given. 3x plus 6 equals 3y. expression, they're equal to each other and they have two unknown variables. Yes, x and y. Same thing with the next one. 12x equals 4y minus 8. 2a plus 2b equals 14. Negative 3n equals m minus 6. And y equals x squared minus 9. All of those are two expressions equal to each other with two different variables. Non-examples, x plus 2, 12 equals y minus 8, and 2a greater than 14b. I wrote as a hashtag have equal signs and two unknown variables. Copy that. I'll give you a little bit of time. Go. Two variable equations. All right, let's move on. Now, the different forms of two variable equations that I gave you in the past, for those of you that were with me, those of you that were not, hopefully this will remind you of stuff that you saw with your other teachers. Here it goes. But I just want to give you ahead of time what they look like. Today, we're going to be working with the first one, which is known as slope-intercept form. Slope-intercept form looks like this. Y equals, and then we have mx plus b. Y equals mx plus b. That's known as slope-intercept form. Why do you call it that, Mr. Q? Because the first letter m is known as the slope. The letter positive b or plus b is known as the intercept. More specifically, it's the y-intercept. That's why it's known as slope-intercept form. Now, how does that look like with numbers? Look up really quick. Y equals 3x minus 2. So by looking at it, if you match everything up, here's a y equals to the y, equal to the equal, x to the x. I can ask you, what is the slope of this equation? You would say what? Show me with your fingers, guys. I see threes, yes? Yeah, 3 is the slope. That's why it's known as slope in green. Slope in green, also the letter m, is what? 3. That's my slope. In fraction form is what? 3 over 1. What is my y-intercept? By looking at it, my y-intercept is what? Show me with your fingers. I see 2, but it's not just 2. It's what? Negative 2. Yes, I saw some of you doing the negative. Yes, negative 2, because it's included with the sign. There it is. And it's easier to match. That's why we're going to be working with these today. The other form is known as standard form. And it looks like this. AX plus BY equals C. Some of you are like, oh, I remember these, Mr. Q. Yes. All of this is review. I'm just going over it to make sure it rings a bell. Now, what does that mean, Mr. Q? It means that both X and Y need to be on the same side of the equation in order for it to be standard form. And we're talking about linear equations. We're not talking about quadratics right now. We know that quadratic equations, it's from highest degree to lowest degree. Right now, we're talking about standard form of linear equations, both X and Y on the same side. How does that look with numbers? Well, let me show you. 4x plus 2y equals 12. Now, if you were to match them, look at it straight down. And if I was to ask you, what is the value of b? Show me with your fingers the value of b. All of you are saying, oh, it's 2, Mr. Q, because it's right aligned right above it. Yes, just by looking at it, if it's in standard form, there it is. The other thing to mention is that both X and Y are on the same side, but which one came first? The X comes first, and then the Y. The last one over here on the other side is known as C, or also C for the constant. The constant is by itself. Does that make sense? Yes, Mr. Q, I remember these. Okay, good. And last but not least, point slope. Point slope is y minus y sub 1 equals m times x minus x sub 1. Why is this one called point slope? Well, because the form says that you need one point and you need what else? A slope. Do you see the slope on this form? Yes, it's right here, Mr. Q, the letter M. The letter M is the slope. All right, but I don't see the point, Mr. Q. The point, they usually give you the point, or I give you the point. So if I gave you the point 2, 3, since it's only 1 point, I label the first one x sub 1 because it's only 1 point, and the 3 is y sub 1. Now that we have those values, do you know where x sub 1 goes? The number 2. Yeah, right here, and the y sub 1 goes right there, and then we solve and leave y by itself, and it's going to end up looking something like this. Okay, For right now, I just wanted to give you the 3 forms just to refresh in your memory, but which one are we going to focus on today in slope intercept form? Are we there? Yes, Mr. Q. Some of you are like, man, Mr. Q, it's like coming like bam, bam, bam. Yeah, I know. Like I said, I'm trying to kind of like mesh what we learned in Algebra 1 and moving on to Algebra 2. Here we go. Next but not least, when we got to slope, before I got to slope, I introduced the coordinate plane. Here goes the coordinate plane. Look up, guys. Whenever we started with numbers, we started with real numbers and we started using the number line. There it is. But once we start with a second variable, we can no longer use a number line above another number line. That's why when we have a second variable, we have to do a number line that intersects the other number line. So it has to go this way. So basically all we did is take this number line, which was X, turn it this way. And now we have all positives here. Now it no longer can be X. Now it has to be a different variable, which is Y. All these negatives are down here, negatives. And now it's part of the Y axis. These are all positives. These are all negatives. And that's the introduction to a coordinate plane. You guys remember that when back in middle school, some of you? Yeah. From there, I said, you know what, guys? And then from there, that's how we introduce the slope using a coordinate plane. But let me show you my Google map. Who remembers this introduction? Some of you? Yeah? Okay, good. And I said, all right, guys, so I'm over here at the high school. And then there were some parents that needed to register their other daughter and son at Frank Wright. And I show them on my phone that it's over here. And I said, get in your car and then drive through these homes, and then you'll get there a little bit faster. And we're thinking, no, that's not how we give the directions, Mr. Q. Of course not. The directions are as given. You say, okay, so you're gonna go get in your car, go through this parking lot right here. But here on the map, if you notice, here's 1 street, 2 streets, 3, 4, 5, 6, 7, up. You're gonna go 7, up, 7, up, or 7, rise. From there, you're going to make a right turn and then go 1, 2, 3, 4. How many of them? 4 to the right or 4 to the run. That's why this is known as 7 over 4. What does that mean, Mr. Q? Yeah, that's what we call 7 over 4 or rise over run. That's why it becomes a fraction. Why we can't use the line. The line is not the slope. The slope are the directions to get from point A, which is over here, to point B. And we always read it from left to right. Is it coming back, some of you? Yes? Yes, Mr. Q, I remember these. All right, good. All right. So from there, I remember I gave you guys directions. Here's the definition: a constant rate of change, and it has to be constant. There cannot be any curves or anything like that. It has to be constant, and it's known as rise over run, or also known as the slope. Steps given. You don't have to write these down, but if you write them, that's fine. Step number 1 says identify 2 points on the line or on the table and write the coordinates. Simple. Step 2, compute the vertical change over the horizontal change. Compute the vertical change, which is the Y, over the horizontal, which is the X. From there, you write your slope and then you simplify it. Once again, this is going to be in your asynchronous presentation. You can copy that from those. That's fine. But like I said, this is just a review. So let us get straight to the part where we practice this. Example Q, copy this. It says, identify the slope of the line that passes through -4, -1, and 4, 3. So I asked you to get some coordinate planes ready. So write that next to the first one that you did. Identify the slope of the line that passes through -4, -1, and 4, 3. We're going to be plotting points, and then we're going to be identifying the slope. I'll give you 30 seconds. Go. All right, so let's do this one together. Let's plot the first point. I'm going to use red for both. So I'm going to start with -4, -1, -4, and -1 is right there. And then we got 4, 3 for the second point, 4 of X, 3 of Y, which is right there. Now, when we're identifying just slopes, I'm fine if you just draw a line segment from this point to this point. And the purpose of that, so that you remember the little map that I showed you to get from here, from the high school to Frank Wright. Do we use this line to count steps? No. How are steps counted? We first start with a rise. And remember, we're always going from left to right. So to get from this point to this point, first I want to know if I go up or downward. So I'm going upward. I go 1, 2, 3, 4 steps, because now I'm aligned to that one. So 4 steps up. From there, I make a right turn here, and then I go to the right. How many steps? 1, 2, 3, 4, 5, 6, 7, 8. 8 steps to the right, or another words, to the run. And this was the rise. Okay, now that I have that, let's write our slope. Slope M, that's the letter we use for slope. We write rise over run. So I'm going to write it again. M equals, what is our rise? Our rise was, since we went up, it's positive 4. And how many to the right? 8. And lastly, we simplify. Can we divide by 1? Yes. Can we divide by 2? Yes. Can we divide by 4, top and bottom? Yes. So this is what? 1 over 2. That's my slope. Slope. Show me your fingers. How come 3 are with these? Yeah. 5, 4 is 5, 4. Yeah, it's coming back. Yes. You're like, yeah, I remember these, Mr. Q. Or I'm going to give you another one for you to do by yourself. You may use the same coordinate plane if you want, but if you created another one, that's fine. Example, I believe Super Q. Here it goes. Yeah, there it is. You already have the instructions. Just copy the points, -2, 6, and 2, 3. Find me the slope from -2, 6 to 2, 3 of the line passing through those points. I'll give you about 40 seconds. All right, so let's see how we did. So I plot my first point, -2, 6, which is up here. My second point, 2, 3, 2, 3. From there, you connect with those 2 points going from left to right, from left to right. So I started the farthest left, which is this one, and then I went that way. So from there, we count how many steps it's going to take us to get to this point. Am I going to count steps up? No, I count steps down. How many steps to align it to that point? 1, 2, 3. Now it's aligned. So that's 3 steps down. Keep that in mind. They are 3 steps what? Down. Yes, and it's still known as the rise. That's the name of it. From there, I make a right turn and I go 1, 2, 3, 4. 4 to the right, or also known as a run. All right, my slope is rise over run. So my slope is, look up, since we took 3 steps down, then we write what? -3. Hands if you did that. Okay, good. And then the run is 4. The run, if you notice, it's always to the right because we always read from left to right. We always read from left to right. That's why it's always to the right. Can we simplify this anymore? Nope. That's our slope. All right. Show me your fingers how comfortable you are with these. Comfortable from 1 to 5? Yeah. 5, 5, 5, 5. Yeah. Am I taking you back to 7th grade, 8th grade? Yeah. And you're like, I remember these, Mr. Q. Oh, yes. Sloppy Joes and frozen pizza. Yeah. Did anybody get frozen pizza yet? All right. Let's move on. Mr. Q, but what if they give me a line and they ask me to find the slope? Writing utensils down, look up to the screen. Look up. Look at this line. Here's the line. They're asking me to find the slope. So what do? Well, we need 2 points, don't we? Yeah, so let me plot 1 point. The easiest point I think I can see right now from the screen is this one, I guess. You guys see it? Yeah? All right. Tell me where to stop so I can plot my other point. Okay, let me do it again. Oh my goodness. Here it goes again. Tell me where to stop.
Stop.
There.
Right here?
No, go back a little bit.
Right here?
No. No, go back, go back, go back.
I'm just going to pick a point. Oh my goodness. There it is. All right. So what do you guys notice? We only need how many points? 2. Does it matter where? No. Pick 2 points. So here we go. From there, I count how many steps it's going to take you to get from here to here, but I need to go upward or downward. So in this case, from left to right, I need to go upward till it's aligned to that. So how many steps up? 1, 2, 3, up. So that's 3 up. From there, I need to make a right turn in 1, 2, 3, 4, 5, 6 to the right or to the run. So that means my slope is rise over run, which is 3 over 6. Can we simplify that? Yeah, 1 over 2. So my slope is 1/2. Now, some of you were like, Mr. Q, how come you didn't use this other point over here? Like, I wanted this point. Who said this point? Hands. Yeah, some of you. How about this point? Who said this point? Okay. Does it really matter? Watch. No, it does not. Because if I was to pick this point right here, look, these 2 points. How many steps up from here to here? 1. How many steps to the right from here to here? 2. So my slope is 1 over 2. Isn't it the same thing as that? Yes. If you pick 2 points that are on the line, since it's a constant rate, you should get the same slope if you simplify to lowest terms. Okay? So with that said, that was me. Copy this next one by yourself. There it is on your coordinate plane. Now this one, for some of you, it's a little tricky because they scaled it by 2s. If you notice, 2, 4. So just, add some in between so like that you know where you're at and you don't get lost. I'll add them for you. Here, 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 here. All right, so copy that line. And they gave us 2 reference points. Find me the slope really quick, please. 40 seconds. All right, so answer. Let's see, how about Viv, what'd you get for your slope?
I got m equals -1 over 3.
-1 over 3. Hands, have you got that? Yes, that is correct. Yeah, because if you went downward, you should have gotten -3, and then to the right, you should have gotten 9. So it would be -3 over 9, simplified to lowest terms, and that's -1 over 3. Okay, so we're done with the simple stuff. I just wanted to kind of like bring you back in regards to what the slope looks like on the graph. Now for home play, you're probably not going to use this method. I just wanted to show you where the slope comes from. Where I want to get to is this next one. Look up to the screen, please. Writing utensils down. Some of you are like, oh, I remember this, Mr. Q. Oh, yeah, I remember I said, okay, guys, well, now that we are far ahead, I'm going to place 2 points on the graph. And you're just paying attention, please. Look up to the screen. And I gave you 2 points. There they are. And when we read this graph, look up to the screen, it's always from what? From left to right. That means that this point, look up, this one right here, this is my first point. So I'm going to label this x sub 1 because it's my first point. And the y value for that one is y sub 1. If I keep going to the right, this is my second point. That means this would be our what? X sub 2. And my y value for that one would be y sub 2. Why? Because this is my second point. And that's if I didn't give you any numbers. However, here it goes. I'm going to graph my segment from here to here. and I'm going to find my slope. So look up. So we said to find the slope, which is rise over run, rise over run. Some of you already see it, some of you still haven't. Let me show you really quick. Look up. Now I'm going to give you numbers. Look up to the screen. Let's say I wanted to get to this point right here, so I need to count steps up. You're like, you don't have numbers, Mr. Q. Or, okay, let me give you numbers. Let's say this is at 7 and this is at 4. So how many steps from here to there? Show me with your fingers. Okay, I see 3s. Yes, 3. Okay. Now I need to count from here to here. So we said that from here to here, it's 3 steps. Okay. But now I need to count from here to here. So let me give you some values for that. Let's say this is 2 and this is 8. So how many steps from here to here? Show me with your fingers. I see 6. Who said 6? Yes. Yeah. Because we start at 2 and then we go to 8. That's 6 steps. So I'm going to write 6. Okay. So now Brianna Romero is going to help me with this next part. Brianna, we said that for the rise, going that way, for the rise, I got 3. Yes? Okay. What do I need to do to these 2 numbers to get 3? Tell me what to write here. We got 3, but now just looking at these 2 numbers, 7 and 4, what do I need to do to get this 3? Tell me what to write.
Do you need to subtract?
Okay, tell me what to write.
7 minus 4.
Hands if you agree. Yes, everybody agrees. Thank you, Brianna. How about the next part? Joshua. To get from here to here, we said that it was 6 steps on the run. All right, but looking at these 2 numbers, tell me what to write.
You write 8 minus 2.
8 minus 2. Hands if you agree with that. Yes, that is correct. Now let me show you now with, if I was to erase those values, I would write the following. What did I do first? 7 minus 4, but now it's what? These 2. So I would write y sub 2 minus y sub 1. How about this? These 2, x sub 2 minus x sub 1. And this is our formula for slope. Copy that, please. Slope formula. You're like, I remember these, Mr. Q. I know. I just wanted you to see where it came from so you understand the slope. And for tonight's home plate, this is what you're going to use the most for numbers 1 through 7, I believe. You're going to use the formula to find the slope. You're like, oh, okay, now I get it. Yeah. Copy that. I'll give you 1 minute. All right. So you should have copied this already. If not, make sure you go to the video lesson and copy that. Let's get started with the practice of this. Here we go. Example 3Q. Copy this. Find the slope of the line that contains 2, 5, and 8, 1 without graphing. You're like, I see what you did there, Mr. Q. Of course. Once again, example 3Q says find the slope of the line that contains 2, 5, and 8, 1 without graphing. Okay. So, like I said, this is recap. This should be coming back into your noodle. So here goes the process. To find the slope, and if they only give you 2 points and without graphing, we can't use a coordinate plane. So that means we need something to work with, which is our formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Next step, we rewrite that, M equals, but on the numerator, I just put a negative in the middle. And then the denominator, I put a negative in the middle. That's the very second step. Why? Because if you don't do that, you're probably going to make a mistake. From there, let's read the problem again. Look at it. We have 2 points, 2, 5, and 8, 1. Which is our first point? Yeah, 2, 5. That means I label this one x sub 1, y sub 1. That means this is our second point. This is x sub 2, y sub 2. And now we have stuff to fill in our formula. I'm going to start with the numerator. We're going to start with y sub 2. What is y sub 2? Oh, y sub 2 is right here, which is 1. Y sub 1 is 5. There it is. Okay, next. What is x sub 2? X sub 2 is 8. And x sub 1 is 2. All right, once we have that, let's compute. What is 1 minus 5? That's negative 4. What is 8 minus 2? That's 6. And then at the end, we simplify to lowest terms. We have m equals negative 4 over 6 divided by 2 top and bottom. So the slope is negative 2 over 3 because we did what? Simplify. Simplify. Show me what famous outcomes you are with these. 5, 5, 5, 5. Okay, let's see. You do one by yourself. Very important, guys. Make sure you write your subtraction for the numerator and the denominator first before you substitute, or else you're going to make a mistake. And I'll clarify that in the next one. Example 3 super Q. You don't have to write the instructions anymore. You already have them. The points given are negative 2, and 7, negative 2. Find me the slope. $30 seconds. All right. So you should have written m equals what was it? Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. M equals fraction form, and then we have a minus and a minus. And I'm going to start with the numerator, y sub 2. Oh, let me label this, sorry. Skipping steps. X sub 1, y sub 1, x sub 2, y sub 2. So y sub 2 is negative 2. Y sub 1 is also negative 2. Let me go to x sub 2. X sub 2 is 7. And x sub 1 is negative 2. Now look up really quick for those of you that made a mistake. We needed to have these negatives there because now we have a value of a negative number here next to it. So what is negative times a negative? This becomes a positive. Same here. This becomes a positive. So that leaves us with negative 2 and 2. That's 0. 7 plus 2, that's 9. So my slope is 0 or 0 over 9. Hands, have you got that? All right, good. All right, so that's how you work finding the slope without a graph. So let's go to the last examples. So what if I gave you example 4? Find the slope of the line given 4x minus 2y equals 16. Copy that. We have this example and one more from a graph, and then we'll finish off. Once again, it says find the slope of the line given by 4x minus 2y equals 16. All right. So for these, whenever they give you an equation, they're asking you to find the slope. Step 1, and here it goes. This is the practice that we did on the warm-ups for about 2 weeks in a row. Solve for y. That means we need to leave y by itself. Step 2, write in slope intercept form. All right, so let's solve for y. Let's see, I need to leave y by itself, so I subtract 4x. I'm left with negative 2y equals negative 4x plus 16. And then we divide by negative 2, divide by negative 2. I end up with y equals negative 4x divided by negative 2, that's positive 2x. 16 divided by -2, that's -8. All right. Is it in slope-intercept form? Let's check. Y equals mx plus b. Is it in slope-intercept form? Yes. So therefore, my slope is 2. And from now on, since we're going to be graphing, write it in fraction form, which is over what? Is it coming back? Yes? Yes, Mr. Q. All right. Show me if anyone shall come to you with these. Yeah, 5s, because we've been doing these on the warm-up, right? Solving for y. Now we just identify the slope from there. All right. Copy this next one by yourself. 6x plus 6y equals 18. You don't have to copy the instructions. 6x plus 6y equals 18. Six x plus 6y equals 18. Find the slope. Example 6 says, write an equation and graph the line given the slope and intercept. So look at this one. Just pay attention first, then you can copy afterwards. So to write an equation in slope-intercept form, we need to write the form first. So I write y equals mx plus b. What does m stand for, guys? The m is our slope. What does the plus b stand for? The plus b is our y-intercept. So now that we know what each part is, I'm going to substitute y equals, let me put the x there. What is our slope? Our slope is -2 over 5. And what is our y-intercept? Our y-intercept is +4. Okay. Are we clear up to right there? Hands, yes? Okay. Let's graph using the equation. Look up, please. First thing I need is my y-intercept. Look up. That means I need to place this point on the y. Where's my y for? Right here. What does that mean, Mr. Q? That my line's going to cross through there. Okay. Next, I need to use my slope to place at least 2 more points. What does my slope say? What is the rise? -2. That means I'm going down 2 steps and 5 to the right. Down 2 steps and 5 to the right. So I go 1, 2, 1, 2, 3, 4, 5. I place my point. From there, I'm going to use the slope one more time to place another point. Down 2, 1, 2, 3, 4, 5. Now that I have those 3 points, I can graph my line going through those points. And that's how you graph a line. Is it coming back? Yes? Some of you? Yeah? All right. And the rest should be like this. Copy that really quick. And I'm going to show you the last one, which is something very similar to these. I just want to show you what it looks like. All right. Before I let you guys go, let me show you the last one. Here it goes. Now, we know how to write a slope-intercept form equation if I gave you the slope and the y-intercept. We already saw that. But what if it looks like this? Give me a second. There's a typo here. Give me a second. That should have been the y-intercept. Give me a second. Y-intercept. So watch. What if they gave you the y-intercept, but they didn't give you any slope? We still need our form, y equals mx plus b. We know what the b is, don't we? What is b, guys? -4, okay. We have the y, we have the x. All we need is the what? The slope. But they don't give us a slope. They give us 2 points. How can we find the slope given those 2 points? Someone unmute and let us know so we can go to lunch.
Slope formula.
What is it?
Slope formula.
Slope formula, yes. You find the slope using y equals I'm sorry, m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Once you have your slope in fraction form, you substitute that in there, and then you graph. Fairly simple? Yep. So that's going to be the home play, guys. So hopefully that review helped, okay? So once again, your home play for tonight, guys, is only 10 problems, which were right here. And notice that the last one is like the one I just showed you with an intercept and 2 points. I mean, yeah, 2 points, no slope. The rest of them should be all the examples that we did in class. All right, guys. Nice seeing you all. Once again, tutoring right after lunch. Be there or be elsewhere. Peace. Have a good one. Bye.
Bear with me, Mr. Q.
Yes, bear with me. Bye.